this supermassive thing that's beyond anything you could possibly, like, it sits inside your imagination. Those are the two options. I think they're both pretty, like, it's pretty crazy to think about, right? I have a bias, and I don't want to really express that bias, but I'm just trying to compare those two ideas side by side.
It's not ad hoc, though, because in order for it to be ad hoc, you would have to say that the default position is heliocentrism. Heliocentrism can only be the default position if you have a measurement of Earth moving around the sun. You can't present parallax as the measurement of Earth moving around the sun because this is the thing that's in contention right now. So that would be begging the question.
No, it wouldn't. You can't beg the question of factual things. You can call it begging the question, but it's not.
It definitionally, very basic, is literally begging the question. We're debating over whether parallax is a proof of heliocentrism. And I gave how it's not mutually exclusive to heliocentrism because it's equally explainable in geocentrism. He said that's ad hoc. I said it's not ad hoc because heliocentrism would have to already be proven beforehand in order for it to be ad hoc. But in reality, parallax is the thing being used to try to prove heliocentrism, and parallax is the thing in question. So we come full circle. It is begging the question.
You're broad stroking heliocentrism. There are many aspects of heliocentrism, not just parallax.
This is painful interacting with you, like that you're not grasping the concept. That's how
Yeah, it is, isn't it?
Yeah, that's what I just said.
It wasn't brought up as a proof of heliocentrism, by the way. We were discussing the dual pole model, which led to the diverging and converging of stars, and that led to discussing like how much a star would move.
Okay.
Like over the course of a night, if you're tracking it with an equatorial mount and all that.
And if any distances of stars have ever been distorted on sky or so. So if you have, for example, like these converging and diverging stars, then for example, the star pictures should be like distorted in some times in the sky and have different distances, angular distances between the stars and so on. And that's not what you can observe.
Sorry, you're talking about the dual pole FE model. Pfinky.
Did you say my name? Yeah, it was in New Perspective was here. We were talking about dual pole.
Oh, my biggest issue with that, like, I mean, like it would serve to explain some things, but my biggest issue with it, aside from like how physical trips around the edges would work, is if you're on the equator and you dead reckon due west or east and you keep traveling, you'll get to a point where instead of the stars just moving straight ahead of you overhead, they would literally diverge and go hard to the left or right.
I don't know if this is an international term, but this is basically fighting pests with cholera. The dual pole model is in so many ways so much worse than the AE map.
Right.
It's just solving one single issue, and it introduces at least 10 new ones.
And keep in mind, the dual pole map is just another projection. You can go with the AE single pole, AE dual project. You can go with any one of those projections. It's just another projection. It doesn't solve anything.
It solves the Antarctic is a continent island or island continent thing. But as I said, this projection specifically, if it's about anything in the sky. And they try to explain 24-hour sun in the south, but that would mean, for example, that on the west coast the sun sets completely due south. It wouldn't set west.
I've seen
never ever. Yeah, go ahead.
Yeah, the animations or simulations I've seen for the sun's motion on the dual pole map, as if it's like special, is a figure 8. Now.
Yeah.
You tell me how the sun's just going to do a figure 8.
And even if the sun would do a figure 8, that would mean instantly on the equinox you have 24-hour night in the north. and instantly on the other equinox you have 24-hour night in the south. But that's not the case. It's a gradual change. You have multiple of days of twilight on both poles simultaneously.
Yeah, I mean, I'm not a dual pole affirmer. Don't get me wrong. Like I definitely don't. Not my model, but I was just pointing out the problem of the divergent stars, like the biggest. But yeah, there's other there's other problems too, of course. But
And flight paths, not to start with, they are already like strange and wrong in the southern hemisphere on the AE map. They are totally bollocks on the dual pole map.
so I've been doing quite a bit of research here lately in my personal time into both like the origins and actual experimentation of Maxwell's displacement current. And I don't know like how much you got, like if anybody in here knows much about Maxwell's displacement current, but dude, it it definitively proves an ether, and it also demonstrates what I call anomalous near field effects, which aren't really, they're not really anomalous. They would only be anomalous in like the mainstream model, but uh, there's a lot of emergent research in like the last 10 years dealing with near field electromagnetic radiation and near field uh, quantum mechanical effects, they call them, even though they're not. Basically, one of my favorite ones, they take capacitors and put them like a certain number of meters apart, and then they discharge. They like create a spark gap across one capacitor and it travels to the other one, and they have the antennas under each one hooked up to an O-scope, and they measure the time delay. And a light speed signal has like in one particular paper, a light speed signal would have to have a minimum 5 nanosecond delay, which is well within the tolerance of what most modern oscilloscopes can measure. And
No, in 5 meters, there are no 5 nanoseconds delay. Definitely not. No, 5 nanoseconds are over more than 100 meter in vacuum, and this is in air. So
oh my
5
gosh,
nanoseconds,
bro,
absolutely
you
not.
just jump in and cut me off, and you're saying a bunch of false stuff when you did it. It just like the worst thing you could have done.
Is it begging the question though?
And this experiment is absolutely poorly executed.
You don't even know what the experiment is.
I know this
Let him
experiment.
finish.
I have read the paper.
This is crazy, bro.
Oh, just let him finish.
1.5 meters is 5 nanoseconds at the speed of light, just so you, not hundreds of meters is 5 nanoseconds. It's 1.5 meters. Go do your math. Second of all, really, you've read the paper? I didn't even give you the title or the authors or the name or anything. Go ahead and tell me what the name of the paper is, since you know.
I don't recall it, but I know that they had issues with the coax cables. They had not properly shielded the complete setup. The oscilloscope was placed in the middle of those, so it would be easily possible that the spark was introduced over the cable, and the measured impulse that they were measuring when this electromagnetic discharge was measured was way too broad and not sharp enough to specifically distinguish that. Their measurement was actually the inaccuracy of the measurement was within the accuracy that they needed to measure it. These 5 nanoseconds, these oscilloscope had something like plus minus 2 nanoseconds inaccuracy, so measurement error.
No.
And they claimed if it was basically 0, then it's 0, and if it was a little bit more, then it's 5. So, and because it was below 5, it was claimed to be 0. That's absolutely ridiculous to do it with this equipment.
Bro,
I read the paper and I checked the data sheets of the oscilloscope. It absolutely makes no sense in this setup. It was very poorly executed.
You know, you literally just lied to everyone in the room. The only thing that you said, I checked everything that you were just saying. The only thing you said that was true was that the oscilloscope was in the middle. That's the only thing that you said that was true.
And the
2
measurement
nanoseconds is
accuracy
wrong.
was also right.
The measurement accuracy thing that you said was wrong.
Nope.
The oscilloscope was plus or minus 1 nanoseconds, not 2. Good try. And it had 600 picosecond steps. Let's see what else. You claim that they didn't use that they had problem shielding. That's not true. They
Okay,
let's see what
because you
else.
claim that the picture they were taking and putting in their own paper was not the actual picture of the actual experiment, right?
What?
You see that they have
the paper.
unshielded parts of the cables there.
It says in text what they use, but hold on. Let me just go ahead and share the paper anyway. It's not the only experiment, dude. There's over a dozen. But for you to butcher the paper in that experiment that badly is like very telling that you just have an agenda to just not want to accept anything that goes against the mainstream. You're just like a mainstream fag, bro. Sorry. Like if you were
Post
at
the
least
paper
going
and
to
we'll all-
address, yeah, if
the
you're
rest
at
of us
least going
can
to
review it.
address things like with accuracy and specificity, that'd be one thing. But for you to just like get it that wrong on purpose is really telling, bro. It's like super disappointing.
Seems like
Well,
he got
instead
some data there. I don't know. Doesn't seem like he was so wrong to me.
Why you lying, Snooz?
1 second.
Why do you have to lie about it? What was wrong with the shielding? Can you be more specific?
Here. The paper's in chat, right?
Give
No.
us details about the inaccuracy of the shielding, right? The incorrect shielding. Give us details about that. What was wrong with the shielding?
They were not using all the time coax cables.
They did use coax
And-
cables, bro. They used 1.5 meter long, 50 ohm coax.
Give us details about what was wrong with the shielding in their cables.
Well, coax is shielded, bro. Coax is
100%. Yeah, if you're using a coax cable, it's definitely shielded. So what was wrong with their shielding in their coax cables? That's his claim.
Yeah, he just made it up, bro. It doesn't even mention
No, I
anything about it
didn't
whatsoever.
made it up.
Okay,
Give us
so
details.
coaxial cables are shielded. So for you to say the specific coaxial cables they used happened to have shielding problems, that would mean that they had like broken or frayed cables of some nature that you would have no way of knowing that anyway. It's definitely not anywhere in the paper. Are you like some like wizard that just has psychic abilities? It's like, oh, I was there when the experiment took place and they didn't use new products. They got some stuff out of the closet that was 20 years old and frayed open.
He might be a wizard, but not with like some sort of abilities, more like an agenda, maybe. So what are the details about this lack of shielding?
What do you know about the experiment they're talking about, Napalm?
It doesn't matter. I just want him to. He said that there was
Oh,
an
it doesn't
issue.
matter. Okay.
Yeah, no, it
Well, I
doesn't.
don't know. I thought
It
maybe
doesn't,
you knew
left
the
lane.
particulars of what difference it would
Let me
make
tell
to
you, I
you
have
about the
zero
shielding
knowledge
of the
of it.
coax.
But this
Well,
guy
what
made
do
it
you
claim
care
that there was like a problem with the shielding. So me with zero knowledge, I'm going to say, hey man, I have no clue about this experiment. You say there's problem with the shielding and the cables. Can you give me details about that?
Yeah, so this
Do I
was
need
not
to have knowledge of that for him to give me details?
So this was not the setup that they used in the experiments, and this is not the picture that they posted in their video.
What video, brothers? What are you talking about?
Sorry, in their paper. In their paper.
What picture is not the picture?
The
what do
picture
you
that I
mean?
posted in the chat.
He just posted one in chat.
Yeah, that's it.
Are those coax cables?
What's wrong with the shielding?
Doesn't look very coaxial to me.
He says the oscilloscope in the center is not the actual one used in the experiment. Is that what you're talking about?
He's talking about
I'm
the cables.
asking you if this is the setup. They post a picture of their setup in their own paper, and I ask you if this is the setup that they were using in their own paper. This picture is from the paper.
Oh yeah, that's part of the setup. Yeah. So if you go to I know it's from the paper. If you go to the pictures page on page, I think it's 5. There's 3 different papers. There's three different pictures. One showing the Wimshurst machine, one showing the the receiver capacitor, and then there's another one showing like how it's all hooked up to the oscilloscope.
So in that picture, where are the cables you're claiming don't have proper shielding?
There's no coax in that picture.
Correct. So
Yeah,
he
but
said
yes,
there was a problem with the shielding
Yes,
on
there
the
is.
coax cables.
There is shield. Yes, there is coax. If you look at the front of the O-scope, channel 1 and channel 2 have two coax cables coming out. One's gray and one's black.
What?
It's blurry, but yeah, I can see it.
These are
Okay,
just crocodile clamps and normal cables, or what are you talking
It
about?
also says it. No, there's a gray and a black. Dude, crocodile clips. Do you know that the terminals, the ports on a oscilloscope don't accept that, bro? You have to have.
No, I mean in the
term-
foreground.
Are
I
those
can see the
coax
ones you're
cables?
talking about. I see the ones you're talking about. The black.
Yeah,
I
and
but
know
are
the
those
ones.
coax cables?
oscilloscope has a BNC connector.
Yeah.
Do you know what a coax cable is, Snooz?
Yes, I know what a coax cable is, and I know what a
So
BNC connector is.
point us to the coax cables that you say don't have proper shielding.
I don't think that's what he said, by the way.
I
100%
say that
what he
they
said.
are using open cables where they introduce the spark plug, and they are not having always coax cables everywhere.
What?
You
What
also
do you
also
mean?
have to shield the
mean
cables where you send the signal. They are sending the signal to the spark plug, and also that signal or that current must be shielded. Otherwise, the sending out of the spark would or of this high current would already send an electromagnetic pulse, even if the spark has not yet happened. And that is a jitter,
What?
and the noise of the whole setup
What?
was
Well,
absolutely
he's
off.
literally speaking pseudoscience word right now, bro.
Dude,
He just
he has
said that
no clue what he's talking about.
he's literally
Yeah.
lost in the sauce. This is crazy that he thinks he's even saying stuff right now. He said before the spark even happens, it would send out an electromagnetic pulse. So there's no spark, but there's a pulse. Like, what are you on, bro? Okay, I'm gonna
So explain
disengage
that
now. I
further
thought
to
that
us.
I gave that no. I gave this guy too much like credit. I thought that there was going to be like something productive in this discussion. He's literally making up stuff. This would be just a huge waste of time to continue talking to someone who says that there's going to be an electromagnetic pulse without a spark. My gosh.
I mean, I
Anyway,
would
so
like
this
to hear him explain that, but it's weird.
yeah, so this paper, if you guys look at it, you go to page 11, and you can see that there's no measurable time delay down to the step measurements of like 600 picoseconds or whatever it is of the oscilloscope between when the transmitter and the antenna under the transmitter capacitor and the antenna under the receiver capacitor receive the impulse. And so they're aligned on the time axis in channel 1 and channel 2 of the O-scope. And they also compare with reference signal. They did these measurements 18 different times, by the way. It's not like they did it just once. They used 2 different oscilloscopes. They changed out all the equipment. They used new cables, new oscilloscopes, new connector. Like everything got changed out that they possibly could change out. And they got the same results every time.
I think like
Yeah.
what I heard his issue is that these clip-on cables. I'm not an expert in this, but he was saying these aren't shielded. Should these be shielded? These ones that are clipped on the edge of the
No, those are alligator clips. So those are connecting directly to the terminal probe of receiver capacitor. It
and should
explains
those be
this.
shielded?
I mean,
Why would they need to be shielded?
I have no idea. I'm asking a question.
I mean, the wires leading up to those clips are shielded, right? So the claim that the point in which it interacts with what it's being clipped to isn't shielded, like
Would
what
not
does that
matter.
take away? So anybody that use that as alligator clips, like anything that they do in an experiment is null and void. That's weird because they use alligator clips for a ton of shit.
I don't know. I'm guessing like it probably depends on the sensitivity of the experiment.
It wouldn't matter if it wasn't shielded, because either way, if you see where those alligator clips are, they're attached to the receiver capacitor, which is still 1.5 meters away from the transmitter capacitor. So the alligator clips are also 1.5 meters away. So whether the impulse from the spark is hitting the capacitor or whether it's hitting the alligator clip, it still has to travel 1.5 meters to get there. It's not like there's just this magic portal in space where it's like, oh, there's an alligator clip in the room. Let me open the alligator clip portal and just teleport the signal there so that there's no time delay. That's retarded.
No, I get that. I'm saying why obviously is important to have the other end shielded. So why not this end?
Bro, that's okay.
I'm assuming that shielding has the potential to introduce, noise into the experiment that could throw it off.
So this is what it says. This is what it says. To ensure the credibility of the experiment and the accuracy of the task, it is crucial to balance the two wired measuring paths, channel 1 and channel 2, connected to the transmitter and receiver signals. We conducted several control experiments to make sure that these two paths have identical and systematic time delay differences of less than 1 nanosecond. This was done to measure the spark radiation propagation speed traveling the 1.5 meter straight path distance, and then compare that to the 5 nanosecond time delay due to the speed of light predicted by relativity. To transmit the signal to the oscilloscope, okay, so this is the part. A 1.5 meter long 50 ohm coaxial cable is used. At the other end, simple insulated wire with crocodile clips, that's the alligator clips you're seeing, is attached, adding another 25 centimeters. There's also a 10 centimeter air travel distance between the spark gap and the dipole antenna. All in all, the total distance of the transmitter path from the spark gap to channel 1 of the oscilloscope is 1.85 meters. And then it talks about channel 2 being same thing, 1.83 meters. The length of the receiver channel wired path is intentionally 2 centimeters less than the transmitter path to compensate for the fact that the transmitter oscilloscope signal travels 10 centimeters on air from the spark gap to the dipole antenna, which is not the case for the receiver. Okay, so it literally just says
he's posting some stuff in chat.
Yeah, the reason that they have the coaxial, or sorry, the alligator clip, right, is one end, right, one end of the alligator clip is clipped onto the end of the coax cable, so it feeds into the oscilloscope, and then the other end is hooked into the dipole antenna, which is receiving the impulse. So the dipole antenna you can't just take a dipole antenna and just hook a coax cable into it, right? Like it's just a piece of metal. So they have alligator clips connecting the end of the pin of the coax cable to the dipole. But talking about shielding is just like wild. Oh, look. This guy's got ChatGPT.
The extent of my knowledge
is ChatGPT.
Is in audio.
Everyone can read that by yourself.
Yeah, so I'm going to just go ahead and tell you right now, ChatGPT hallucinates when it comes to scientific papers, especially if they contradict mainstream opinions. I already went this whole road with ChatGPT.
Yeah, then verify all the claims. Verify the claims that they were made in the analysis yourself.
So
you will see that they are correct.
This first picture says that they have 1 gigasample a second, which is 1 nanosecond sampling interval. That is correct. But then it says they define anything less than 4 nanoseconds as a null result and therefore instantaneous or superluminal. So they're trying to resolve a 5 nanosecond effect with an instrument whose effective timing precision and system jitter are of the same order or larger. That's not true at all. See, this is the thing. I don't know if you know this. ChatGPT is a relativity propaganda bot. You could literally give it an experiment and say, hey, look, this happened. It directly contradicts relativity on its face. They'd be like, that's nice, but the overwhelming majority of scientific evidence points that it's a very robust theory, blah, blah, blah. And then they'll say, maybe you had measurement errors in your experiment. Like, they'll literally start trying to do that to you. You can't just treat ChatGPT as like the final word on anything, bro. The transmission minimum time is 5 times higher than the resolution sampling of the oscilloscope.
Okay, why are they writing literally in their own paper? And I'm quoting now. any other result obtained less than 4 nanoseconds will be characterized as null result and instantaneous superluminous signal propagation in the near field obtained. This considered a control experiment, and we believe that no less than 4 nanoseconds measured is possible for a conventional physics explanation.
Yeah. Did
They
you
write
hear?
it literally in their own stuff. So 5
Yeah.
nanoseconds would be the light
Uh,
speed, and 4 nanoseconds is be characterized due to their jitter and measurement inaccuracy as okay. There's nothing happening. There's no time happening.
So you didn't understand what I was trying to say with this statement. I read what it said, and I said it's wrong because it says that the timing, precision, and system jitter are of the same order or larger. That's the part that's wrong. I didn't say the part that was. I literally said that what it says about the oscilloscope's correct. Okay. Defining anything less than 4 nanoseconds is a null result. That's correct. It's the part right after that where they say they're trying to resolve a 5 nanosecond effect with an instrument whose effective timing precision is of the same order or larger. No, the timing precision is 5 times smaller than the minimum travel time.
No, there's
not larger.
minimum measurement accuracy is 4.
Okay, you know
nanoseconds.
why that is? That's because 5 plus or minus 1 is 4 to 6. Therefore, it can't be anything less than 4. Because the resolution of the instrument is 1.
God. Okay,
So you take 5 minus 1, and that's 4. A 1 nanosecond oscope can see 4 nanoseconds all day, every day.
People can read it themselves.
But yeah, I'm sure they can read it themselves. That's why I posted it in the chat so they could. But the point is you can't escape the fact that the signal absolutely has to take a minimum of 5 nanoseconds to reach the receiver. It can't get there any faster, or relativity is wrong, period. It's 1.5 meters away. 1.5 meters at the speed of light is 5 nanoseconds. So, channel 2 on the oscope has to have a 5 nanosecond delay, or 4 nanoseconds if you do plus or minus 1 for the resolution. They did not get that. The entire time window on that one picture is about 5 nanoseconds, meaning that the signal should be shifted from one end of the time window to the other end of the time window on channel 2, and it's not. They overlap perfectly in terms of when the first movement from 0 happened, when the impulse is received.
Well, I mean, I guess this means we can send data faster than the speed of light.
Well, energy is information, right? They say energy because energy is what caused an electromotive force in the antenna, which produced a voltage which ran down the wire and ran into the oscope. So a voltage was created, work was done on the antenna.
Yeah, so make it flip a bit, and we got faster than light communication. No.
Yeah, you're right.
They don't like that though. You have to dismiss it in some way, shape, or form, right?
I mean, he's totally right. I mean, the fact that there's a voltage, there's a signal picked up, that the signal was transmitted. That signal is information, bro. That's a complex set of information. It's more complex than bits.
So was that one of their conclusions? Is that we've cracked the ability to send data faster than the speed of light?
If you go to their conclusions page, 1 second. Section 3 is actually really good as well because it shows the math that predicts this. But
I feel like this isn't the only time it's been done. It's been done multiple times, right? But it's always like,
a lot.
Yeah,
there's
but it's always
13 other papers referenced in this paper.
Yeah, let's find a way to make sure that we can't actually claim that this is what happens because of what we know, right? We know that the speed of light is, the only speed limit to the transmission of information, right? Since we know that something had to go wrong with the experiments, but every time that it happens, it has to be explained away, right? That's what always happens.
This is a fairly simple experiment. I think
Very simple.
we should be able,
Simple.
like you should be able to demonstrate transferring data faster than the speed of light. My guess is that like when you actually get to doing that, you're not going to be able to do it.
No, the reason that happens, Pfinky, is this is in the near field. So they particularly were paying attention to the wavelengths of light or RF wavelengths that were much longer than the distance between the antennas. So they filtered out for 150 meter wavelengths, and they were 1.5 meters apart. So 1/100th of the wavelength was the distance. So they're in the extreme near field. And it's only in the near field that this happens. Because once you reach a distance of one wavelength away, then the velocity falls off to normal C. It's only in the near field that it happens. And so that's what I was bringing up. And there's other effects too that happen in the near field. I don't know if you know this, but
A bunch of like little repeaters.
Yeah, exactly. But it'd be complicated. But yeah. I mean, on small scales, you could definitely do it. And every single circuit board, brothers, capacitor components, those capacitors, the plates are so close together that they're all operating instantaneously, or almost instantaneously, right? Not literally, but highly superluminally. But you'd never know it because it's already like nanoscale architecture anyway. You'd never be able to measure that. But
I mean, if you're talking about CPUs, you'd be able to measure a difference in the processing speed. No.
not the processing speed, bro. I'm talking about when you have these nanometer scale circuits, and you have a capacitor, and the two capacitor plates are like, picometers apart. You're not going to notice a difference on the signal travel across picometers, but if it's C or 10C, like it's so infinitesimally small, the difference, right? But you'd have to do specific measurements just to figure that out. But anyways, where I was going with this is there's all kinds of near field effects. So like this is Maxwell's displacement current, right? And I don't know if you know about heat transfer, but there are three forms of heat transfer: conduction, convection, and radiation. And recently, you can look this up, it'll pop up very easily if you search for it. They were able to demonstrate non-radiative vacuum heat transfer in the near field. So they were able to take these two silicon wafers and space them like, I think it was like 550 nanometers apart, something like that, 400 to 600 nanometers apart, which is, hundreds of times larger than our CPU architecture, right? So we're talking pretty big distances in terms of computer chip scales. But they took two silicon wafers and put them like, 500 nanometers apart, and they heated one of them up, but not the other one. And they were able to get the thermal weight, like they heated it up very precisely with whatever they were heating it with, whatever heating method, to where the thermal wavelength, being inputted into the silicon was much greater than the distance between them, so that it was in the thermal vibration was in the near field. If you were to treat that as a traveling wave, it would be near field. And they were able to see that not with radiation, because they measured that there was no light coming off, there's no RF coming off, and definitely no conduction or convection, because number one, it's not touching the other wafer, number two, it's in a vacuum. They were able to get a temperature increase on the second wafer just by heating the first one. In other words, the thermal energy inputted into the first wafer traveled across the vacuum and heated up the second one without touching it. Near field, non-radiative vacuum heat transfer.
That sounds cool.
Yep.
Sounds cool. I have no like when I hear stuff like this, I'm like, I highly suspect like that there's an effect that's like we can't actually transfer data faster than the speed of light. There's something in it that's not going to allow that. And if you could, which that would be cool if you could, you can't, like, that's not something you can suppress. There's too many people that would be able to make money and take advantage of that I think it would be really obvious really fast.
Well, you say data, right? Like really the word you should be saying is information. Any causal change is information.
I said a bit. Like everything in a computer is just a flipping of a bit with an electrical impulse. So
Right, I get it.
if you can send that faster than the speed of light, you have a $1 trillion improvement in
Well,
from
okay,
the source of things.
so
So
there's
if
plenty
that
of
happens and that pans out, that would be very, very obvious evidence. I'd ask you too, like let's say they can't, like for whatever reason they try and they realize like you can't actually send any information across it. Does that
well, that's what
what
I'm
is
talking about. Like, what is information, right? So when
a
you
bit?
say if
Like
energy is sent,
you can't flip a bit across a line faster than the speed of light.
okay, I'll give you an example of exactly how you do that. So this experiment already did it, but I'll give you a second one. Let me start with this one real fast, just in short. When that dipole antenna at the receiver, underneath the receiver capacitor, felt the impulse coming off the Wimshurst machine, that impulse stimulated a voltage in the antenna, which traveled down the wire and into the oscope, which outputted it on the screen. Right, that was a signal, that was energy, and that was information. And that obviously, traveled with no perceivable time delay. There's
Yeah, but it has to
other.
be. Sorry, it has to be where the information originates. Like it has to originate at the start, send it across. Like it's not just enough to say, "Oh, we received a message," right? 'Cause you have to be able to send discrete bits. Like you have to be able to send a stream of them that each one travels faster than the speed of light.
Well, you're talking about encoding right now, right? Like
No, I mean it's no because
information got sent. It's not like at this point. It's not anything that was encoded. It was just a burst. It was just a spark gap creating an arc flash that generated a bunch of random, like effectively RF noise.
that's fine. That's like if you can detect it on the other end, in my mind you've sent a bit across. But you have to be able
Right.
to do that where you say I'm going to send a 1 and a 1 and a 0 in that sequence and be able to send those three faster than the speed of light.
I mean,
That's
you're
what would have
talking about controlling and encoding it now. Like what we've
well, if you can
established.
turn it on and off, if you can send an on or an off, then I don't see how that's any different than encoding. Right at the core of it, everything we send over the internet, they're just electrical impulses.
Well, if
across
it's
Cat5.
5 nanoseconds away at the speed of light, and you're able to do like spark gapping faster than 5 nanoseconds, like if you're able to have it happen every 1 nanosecond, so you'd be able to send 3 of them. All 3 of them would get there with less than a nanosecond delay, so they'd all get there in less than 4 nanoseconds. So you'd have sent three of them. Now, doing 1 nanosecond switching is really hard. I mean, you'd have to have some crazy high frequency going to your Wimshurst machine to get that to happen. But, like that's just a thought experiment. But then,
that would be that to me. That would be really compelling.
I mean, we've transmitted energy, bro. Like that's once you did work on the antenna and then there was a voltage produced. That is energy. We know when it got there. I mean, Gunter Nimps in '95 sent Mozart's 40th Symphony at 4.7 times the speed of light using 2 radio antennas and prisms. Hache and Poirier, we talk about them a lot in here from time to time. 2003, they used a 120 meter long coax cable with switching back and forth A and B refractive indexes, creating a gradient that like flipped back and forth all the way across the cable, and they transmitted pulses between 8 and 11 megahertz, or 8 and 12 megahertz, 8.5 to 11.5, something like that, at 3 to 3.5 times the speed of light. And then people start talking about, well, is it phase or group velocity? Most of the time they want to say, oh, it's only the phase velocity. In this case, it actually was group velocity, which is the part that carries the information. But then people started trying to make crazy explanations and say, oh, well, if you read the paper, it says, while this may appear to violate causality, no useful information can be sent. So they were saying like information is sent, but the information is not useful. So then they're like adding this arbitrary definition of what is useful information, as if like the subjectivism of what a human thinks is useful matters at all.
I would think, assuming that they're, I don't know, like if you can send a bit is useful information. So if they can't send a bit, then yeah, they're not sending. Like that feels like the bare minimum that you'd have to be able to send in order for this to be considered sending information.
Flipping the detector on is a bit, bro. It's in a default off state, which is a 0. It turns on, that's a 1.
I know, I get that. I'm just saying we have people who have supposedly sent Mozart's symphony at faster than the speed of light, and we're still sitting here. Nobody's been able to turn that into, something that we can actually use.
Well, yeah,
and that to
because
me
all
tells
these
me
effects.
that to me tells me that there may be something in it that like we're measuring something that's not.
Because you have to do special stuff to make this work, bro. You can't just send a signal from like here to from New York to California.
I get that with the
at
wavelength.
speed.
I get
Yeah,
that.
you have to either use near field effects or prisms. You have to anomalous dispersion in materials. So like, yeah, we can do it across a 120 meter long coax cable. We can do that all day. But what does 120 meters help you in the scheme of information transfer in the world?
I think it helps a ton. You have like major routing hubs where you have internet traffic coming through, and then you're trying to like move it through, from router to router to try to get it out on the right line. And a lot of those things happen at short distances, much shorter
Oh
than
yeah,
100.
yeah. Also, I forgot about adding this. Another problem with it is that the anomalous dispersion, like when they used, because basically what happened is at the boundary condition between A and B of the two different refractive indexes of the coax cable segments, there's like that instantaneous change, and then it changes back from B to A, and then A to B, B to A. It keeps doing that. So what it does is it actually drops the effective refractive index of the material to less than 1, which is what speeds it up. Right, it's actually going faster than instead of slowing down. But what it ends up doing to the waveform, you can look at the pictures and the diagrams in the paper, where you start out with this normal like sinusoidal waveform at the non-anomalous wavelengths, and then when you get to the band gap region, the wavelengths that interact with the boundary conditions to go superluminal, the sinusoidal waveform gets squished. Yeah, it's that picture he just posted. So it goes from that first picture to that second picture, or that first trace to that second trace. So that one above gets squished into that second one, and that's why they can't read it, because essentially, it's like a corrupted data packet now, right?
Although, like if you know it's going to be compressed or it's going to be distorted in a certain way, it feels like you should be able to still.
No, it's not.
Yeah.
No, the thing is, this what you see there is a single pulse. It's a single pulse that they send over this signal. It's a burst. That burst, the sine wave there, was in the end. So on the left side, the top is a sending signal over a normal coax cable or a normal photonic crystal that has no periodic impedance difference, and the lower signal that was sent has this periodic impedance impedance difference, which causes reflections in the cable that basically dampens the later coming signal. So the left part of that bluer signal at the bottom is basically dampened to be shorter or less amplitude, which means the center of mass. So the group velocity center, which I made with a circle there, arrived earlier. So if it arrived earlier than the control signal at the top, it was basically faster than the speed of light. So in that screenshot, it was basically double the speed of light because it was 0.4 roughly microseconds earlier than the control signal. But that beginning of the signal on the right side was at the same time. All these sinus peaks were at the same time. The signal just kind of degrades earlier, which means the group velocity is there earlier. It's
What's
like
the group? Can you define the group
example
velocity real quick?
that I brought when I discussed this with Witzit was also, it's like you throw two spears at the same time, but the one spear in flight you cut in half, which means the center of the spear is now before, so the center of the short spear is now before the center of the long spear. And that's the only thing here. The tip of the two spears that you have thrown at the same time, at the same velocity, is still at the same point. You just have shortened the one spear, which shifts the center a little bit to the front.
That's
And
not
that
how that
whole
works.
signal that they sent, the whole signal that they sent over this 120 meters was 6 to 2 microseconds long. So that was the signal length. It takes only 0.4 microseconds to travel the distance. So it was a long chirp they were sending there.
Do you see how in that picture above, the front and back of those two pulses are at the same spots? Those pulses are the same lengths.
No, the back is, I mean, you see it from the top part. You don't see it until it goes really low. So
If I
yeah.
can, okay, I'll take your picture and I'll put it in paint, since you want to be like this with every single thing you talk about tonight.
It doesn't start at absolutely zero signal, and it doesn't end at absolute zero signal. They have a cut, like a crop of the signal from the center of the control signal. So the top signal is a control signal that they send in the normal coax crystal, and the bottom one is the one with the alternating impedance. And so the top one defines the zero. So the maximum peak, or the center of mass of the control signal, defines the zero. And this frame, what you see here, is just a plus minus 2 microseconds crop of the whole signal. And in that crop, you can see that the center of mass of the lower signal is shifted forwards because the end is dampened earlier.
So you're telling me that if you look in the chat right now, the picture I just replied to you with, that those two pulses aren't of the same length? Because I just put vertical lines
Okay,
in the front
I
and back.
specifically addressed that point. I don't know if you did not listen, but I specifically said this is a crop of a longer recording of just this 3 or 2.5 microseconds plus and minus. This is not the full signal from the build up to the complete zero again. They just made a centering on zero of the control signal, and then they had plus 2.5 microseconds to the front and plus 2.5 microseconds to the back. And then they cut it. There's a hard cut. There is no zero line. There is no going down again, and so on. It's not the start and the end. It's a crop. You know what a crop is?
Yeah, so let me ask you a very common sense question. Actually, it's a two-part question, but let's just try to keep it short and concise, please.
Sure.
How do you define the group velocity? That's the velocity of what part of the wave or the waveform?
The group itself is defined by basically the center of mass, which I visualize there with this circle.
Got it.
And if this circle, the one circle, is before the other circle, then the group velocity of the lower signal was faster than the group velocity of the top signal.
Okay, so yeah, okay, so the group velocity in this paper, they say that the method that they used to measure it was the center of mass. Now, you have not shown in your little picture there that you're measuring the center of mass, because what the center of mass would be the center point where the left-hand side and the right-hand side of it have an equivalent amount of integral of amplitude.
Yes.
And right, so you're not showing that here.
But this is exactly what I have shown there.
Hold on a second. Yeah, I'm seeing way more squigglies on the left side of that circle than I do on the right side of that circle for the purple one.
But they are way lower. Don't you see that the first amplitude of the both signals are way bigger than the last on the very left side of the lower signal? So the up-down, the amplitude, that is, how do you say, like running out?
The entire
On the
amplitude of the
lower
bottom one's
left
smaller.
signal, it's way smaller. It's just a crop. It's a crop of that. It's just a cut off of 5 microseconds of this whole signal. It's not 10 microseconds from the very build up to the very end where you have a flat line again. You don't see the start and the end of the whole signal. This is just a cut of the middle. As long as you
Yeah,
don't
so
see a flat line in the very front and a flat line in the very end of both signals, you have no clue what's coming before and
yeah,
then in the
yeah, I
end.
think you're missing
What
my
we
point. My
can is
point is that you are literally eyeballing this to try to say where the center of mass is.
I'm visualizing it. I'm visualizing it just to show the people what they mean with the center of mass shifting forward.
Okay,
Of course,
dude.
this is not a scientific accurate measurement because I don't have a raw
Yeah.
data. I just have the picture
Okay.
they posted
So
in
let
the
me go back to
paper.
my two questions now. I said let's keep this concise. I know you're not capable of doing that. You're not able to. I know, but I tried
Because
anyway. So
you try to
okay,
deflect and
I'm
try to
asking
introduce
you the
that this
question.
signal
So
is a full signal.
the center of mass, right? Because the actual definition of group velocity, group being the entire waveform as a whole, that is the group velocity. The group, this velocity with which the entire thing moves, or the average. And the way that you can do that, you can measure it a few different ways. They chose the weighted center. Now, that's the group velocity. Let me ask you this: what is the front velocity of a wave?
The very start of the signal.
The very tip, right?
Yeah.
Okay. So so now here's another common sense question. If we are measuring, right? If we are measuring, when does the detector receive the signal? Is it the very, very first non-zero blip on the detector? Is that going to be
Yes.
received from the front? Yes or no?
Yes.
Okay, perfect. So the front always arrives before the middle, right?
Yes.
Okay, common sense, tracking, good. Okay, so if we are measuring, right, if we are measuring how fast the middle gets there, right, how fast the middle gets there, is there any possible way that the middle can be traveling faster than the front?
No.
Okay, so the middle cannot be traveling faster than the front. So if the middle arrives with a speed that's 3.5 times the speed of light, that means the front has to be at least that fast. That's the conclusion you just reached. Which means superluminal energy transfer.
Sorry, no, this is not correct. So the
Oh well,
middle
you
can no, wait a
literally
second.
can't say it's not
Can
correct
you
because you
also
already agreed to
let
every
me
premise
answer?
before the conclusion. That's the logically necessary
No.
conclusion you just
No,
drew
you're
by
wrong.
agreeing to all the other questions beforehand.
You're
Yep.
wrong in your conclusion. So the
No,
middle
I'm
does
not.
not. Can you now also let me talk? I let you talk as well. So the
This is
middle
hilarious.
can travel fast. The middle can travel faster than the tip.
You just said
It
no.
does not mean the middle. Can you stop talking while I'm talking? I let you talk as well. Don't
You
interrupt.
just said it did. It
Can
couldn't.
you
I
stop
asked you,
interrupting,
why did you change your
please?
story?
Because I want to explain it. I said the middle cannot arrive before the front, and you concluded, therefore, the middle cannot travel faster, and that's
I
not
asked you
correct.
explicitly both of those. I said which arrives first.
And I
The fr-
tried to answer, but you kept talking. So can
no,
I now explain? And
nobody. Dude,
if I
you
said
are
yes,
a bold-faced freaking liar, bro.
if
I
I
cannot
said
stand
yes, I
liars.
was wrong.
Hold on.
Hey,
Who's got the recording? Who's got the
why,
recording?
why, why are you
How
not
much
shutting
money?
up?
How much money
Can you shut
are you
up
gonna
while
pay
I'm
me when I prove
explaining?
that you're a liar? How much
Are you
money?
that a dishonest prick that you cannot shut up
Okay.
while I
Bill,
want to
Bill,
explain
Who's got
my
the recording?
no
answer?
name
Who's got the
calling.
recording?
No name
Where's the
calling.
stream?
No name calling.
So,
Here's the thing. Either prove it or don't prove it, right? You don't need
Yeah,
to
where's
name
no,
call.
it has nothing to do
You
with
don't need to
proof.
get
Can I
butthurt
now
about stuff.
explain?
So
You're clipping me all the time. I
where's the
want to
stream?
explain my
Where's the Earth
answer.
Awakening stream?
Can you shut the fuck up for a
I
minute?
asked you.
clip
I
it,
said,
bro.
Can you shut the fuck up
I
for
said,
1 minute that I can correct myself?
yeah, can
If
the
I
group
said
velocity
yes,
travel faster than the front? And you said no, it can't. And I said perfect.
okay. And what I meant is it cannot arrive. And now I want to correct
We
myself and
asked
said it's
both. No,
not.
I asked
Can you
both,
shut
bro.
up? You are just a dishonest asshole that you cannot shut up and
I'm
let me talk.
dishonest.
You are
You're
clipping me for 5 minutes straight now. So I try again. the middle can travel. So if I said yes to it, or if I said no, it cannot travel faster, then I was wrong before. The middle can travel faster. It cannot arrive before the front because that would make it the front. But if you have a group, let's say 100-meter group, and the front person runs with 10 miles an hour, and the last person runs with 20 miles an hour, and the middle person runs with 15 miles an hour, and they are running only so far that they are still behind each other, then the middle is traveled faster than the front. So, and that is exactly what we have here. The group velocity is the group in the middle, and because the signal gets shorter over the travel or over the sending time, that automatically means that the middle of the signal, because it gets shorter over time, has traveled faster with a higher speed than the front, not arrived earlier. That is a difference. And you try to claim or so that it arrived earlier, which is not the case.
So when we look at this chart, right, you're talking about the back and the middle running faster than the front so that the pulse is shortening itself as it travels through space, right?
Correct. The signal is shortening itself because on every alternating impedance of the signal, there are caused reflections. And these reflections are dampening the second half of the signal because you have these reflections on cables. And this is why you, for example, had in old-time coax network, you have resistors, you have the N terminators to reduce the reflections on impedance chains or on open end of cables. And they specifically made here an alternating impedance on the cable so that on every impedance over like border between the 50 ohm and the 75 ohm, you get a little bit of reflection. Of course, the front of the signal is not affected by the reflection, but the end of the signal is affected by the piling up reflections on the signal, which and this is what you see in the picture. You see a signal that got shorter. This picture is clearly showing two signals. The one signal is longer, the top one, and the bottom signal is shorter. They are starting at the same time with the same amplitude, and the bottom signal is, for once, in the general amplitude, it's smaller. So it's not only shorter, also the amplitude of the signal itself, the signal is definitely shorter. You see that it decreases in amplitude earlier than the other signal.
Okay.
The top signal decreases in altitude in amplitude later than the bottom signal. The bottom signal
The shape of
earlier.
of the waveform, the shape of the waveform is changed. The length is not.
Yes, it is because this is a crop.
No,
and if
there's
you
a
see,
picture there, bro.
you see here the signal in the y-axis.
Such brain rot, dude. I don't want to
And
talk to
if
you
you
anymore,
see
bro.
when
Like
the
I'm
signal,
tired of
if you see,
not only are you lying, you're literally looking at a picture which is a factual piece of information that's not up for interpretation in front of your face with two vertical red lines on it, and you say, "Oh
Yes.
yeah, those vertical red lines touch the waves at the same point on either side, but the bottom one's still shorter though."
So you're
done
so
with you, bro.
dishonest that
I'm
you
done with you, bro.
claim that these two red lines
I'm
are the
disengaging
literal
now.
start and the end of the signal.
I'm
And these red
disengaging with you
lines
now.
are not the start and the end of the signal. You are just trying to confuse the audience. It's a crop of the overall signal. It doesn't start with a flat line. You do not see the start of the signal, and you do not see the end of the signal, the other flat line. It's just the relevant section of the middle when they calculate the center of mass of that signal. And that signal, by the way, is not for once on this line. This signal travels with 0.4 microseconds. And the whole signal is 5 or 6 microseconds long. So it's over 10 times the speed of it taking the distance. It's on the it's sent.
So I have to say that as a neutral observer, Snooz's claim that the pulse is getting shorter, that it is contracting, seems to be absolutely true. The area over which the power is spread seems to be contracting. I don't see how you're arguing otherwise.
Thank you, Tony. I appreciate the honesty. I have to go to breakfast now. Tony, by the way, would you also agree with me to determine the actual full length of the signal? You have to see the flat line in the front and in the end, because this is clearly a crop of a signal time.
Yeah, this is a cropped signal. Clearly that you would have to use more sophisticated techniques to actually identify the beginning and the end. But yes, and I would say that the rate of attenuation of the signal at the end, where you define the signal, the end of the signal, is going to be something of a judgment call. But certainly, if you look at where the area in which the signal is above, say, a threshold amplitude, that has certainly reduced in the lowermost of the two examples. So it is more condensed. It is covering a smaller area, a shorter duration. So the claim that it is not is simply counterfactual. But it's interesting. It's an interesting phenomenon to see. There are multiple examples from astronomy where you appear to see superluminal signals, and they're sort of optical. They're optical illusions, because you can see the component that's lateral to your field, that's across your field of view, but you can't see the component that's towards your field of view.
But this experiment isn't even that complicated. It's literal, like they have a 2-channel oscilloscope. They send it over one normal cable and one periodic impedance changing cable. And overall, you also see that the control signal has a higher amplitude in the max amplitude than the actual, like the test signal on the bottom. So already the test signal is dampened due to reflections on the cable.
Exactly. Yeah. So this is a very clear example, and I think you were describing it with great precision. But you're getting pushback from, because I think there's an ideological need to dispute what you're saying. But the accusation that you're lying about this, or that you're misrepresenting what's shown in the figure, is just an outrage. Is not one that I agree with. I don't think that claim is defensible at all.
Well, they even claim in the paper that it seems to be superluminous, but it's not. Yeah,
I mean, this is often the case. You can see sort of group velocities that are that seem to be superluminal, but if you're looking at the individual waves or the individual information, all of it is limited. All of it is, 'obeys relativity. And the thing is that a group velocity depends on a combination of waves, and if the individual component waves are affected by some sort of bias, as you pointed out, where the rearmost elements of the wave are damped or attenuated, then sort of, as you say, those waves are going to be suppressed, and the group velocity, or the peak wave of the group, is going to move closer to the front of the signal, and that's got nothing to do with any of the waves actually traveling faster than light. But this is the guy who was obsessed about the Ryu Yang Wang experiment. Is that right? Which I did read up on, and the literature on it seems to thoroughly debunk what he was claiming.